Hello, you guys. It's Lakita from Apex Nursing Academy. I decided to do some nursing dosing calculations today. So I thought I would come on and do some. Maybe you guys want to practice doing dosage calculation problems. I use dimensional analysis. I find it to be pretty easy. I used to try to use formulas, memorize formulas, write them down, try to memorize them, which it works sometimes, but I find that dimensional analysis helps me just work through the problem a lot easier without worrying about memorizing and trying to remember um, a lot of formulas for testing. So try some problems with me. Let me know how you guys like dimensional analysis. Let me know if you want to see more problems with dimensional analysis, and we'll go from there. So the client has hydroxyzine 75 milligram IM stat ordered for severe motion sickness. The pharmacy has available hydroxyzine 50 milligram per milliliter. How many milliliters will the nurse administer? So when I'm doing dimensional analysis problems, I go right into looking up what they are asking me for. I go right to the question, how many milliliters? How many milliliters? And that is what I start my problem off with, whatever they're asking me for. So I take milliliters, I put it there, do my equals, and I go and I look for milliliter in the problem. What do we have available? How many milliliter? 1 milliliter to 50 milligram. That's what we have available there in our problem. So I plug that right into my first setup. Now, the thing about dimensional analysis is an easy way to do it is to use the denominator, the unit of measurement in the denominator. That is what's going to guide you to what's going in your numerator in your next setup, right? So now we have milligrams in our denominator. We know we need milligrams in our numerator. We go back to our problem and we pull our information and plug it in. 75 milligram. Now we can cancel out milligrams. Remember, you have to have a numerator, have it in the numerator and the denominator to cancel out. Milligrams can cancel out. We only have milliliters left. Now we can solve. 1 times 75 is 75. 50 times 1, if you need to put a 1 here, you can. 50 times 1 is 50. Don't forget to bring your measurement over here so you don't forget. And then you just work that out. 75 divided by 50 is 1.5. 1.5 milliliter. And that's our answer. And that's really the basis for dimensional analysis. You just set up your problem. Let's do another one. A preoperative client complains of anxiety and has Ativan 2 milligram IM Q6 hour PRN ordered. Ativan 4 milligram per milliliter is available. How many milliliters will the nurse administer? Again, how many milliliters is what it's asking for. So that is what we're going to start out with. Milliliters. Milliliters equal. What's available? 4 milligram per milliliter. So 1 milliliter to 4 milligram. Then milligram is in our denominator. That's going to guide us for what we need in our numerator. Let's go to our problem. Get our information, 2 milligram. And milligram can cancel out. We only have milliliter left. Let's solve. 1 times 2 is 2. And then we have 4. If you need to put your 1 there, you can. And divide that out. 2 divided by 4, we have our answer, 0.5 milliliter. Okay, so dimensional analysis, it kind of tells a story. It guides you as to what comes next. And you just keep plugging in, putting in all your information from your problem to solve. Let's try another one. A healthcare provider orders naloxone zero point 0.6 milligram IV stat. The pharmacy supplies naloxone 400 mics per milliliter. How many milliliters will the nurse administer? We're looking for milliliters, so that's what we are going to start with. Let's see how many milliliters do we have available. Supplies 400 mics per milliliter. So 1 milliliter to 400 mics. So we need mics in our numerator. What do we have in our problem? He orders 0.6 milligram. Okay, we got 0.6 milligram, but we need mics. So this is where you plug in your conversions. And that's one thing too that I like about dimensional analysis is that you can plug in your conversions right into the problem. You have to remember your conversions, but if you can remember that, which we know that 1 gram equals 1,000 milligrams, we remember that, right? And 1 milligram equals what? 1,000 mics. We got that. So we can plug that conversion right into the problem and keep going. So 1,000 mics is to 1 milligram. Now our mics can cancel out. Milligram is in the denominator, so we can plug it in the numerator now. We can plug in our 0.6 milligram in. And now our milligrams can cancel out and we're left with our milliliter, which is what we're looking for. Put a 1 here if you need it. Don't stress yourself out. If you need to see that 1, put it there. Then we solve. 1 times 1,000 is 1,000. And 1,000 times 0.6 is 600. Don't forget your measurement. 400 times 1 is 400. And if we divide that out, which we will, we get 1.5 milliliters. And that's our answer. So don't be afraid if you see where you can't go right into your next measurement that you need, because you know you can always plug in the conversion, put it right in the problem, and you can still come out with your correct answer. Let's try another one, you guys. The healthcare provider orders ascorbic acid 0.25 gram IM daily for the client admitted with an alcohol abuse problem. The pharmacy supplies ascorbic acid 500 milligram per milliliter. How many milliliters will the nurse administer? We're looking for milliliters again. So that's is what we will start with. How many milliliters do we have available? Supplies 1 milliliter to 500 milligram. Milligram is in our denominator, so we're going to be looking for milligrams in our numerator. We're going to go to our problem. Ascorbic acid 0.25 gram. Once again, we are not going to get nervous. We need milligrams. So let's get there. Let's get to milligram. Remember, 1 gram is 1,000 milligram. So 1,000 milligram is to 1 gram. Simple as that. And we're going to keep rocking. We got our milligrams canceled out. Our gram, let's get our grams canceled out. 0.25 gram. We had to go to our problem, remember? 0.25 gram, put a 1 there if you need to see that. Grams cancel out. Now, let's multiply 1 times 1,000. Of course, it's 1,000. And 1,000 times 0.25 is 250. We're not going to forget our measurement. 500 times 1 is 500. We're going to divide by 500 and we are going to get 0.5 milliliter. And that's our answer. So there you have it. That's all that I have for today. Man, I was on a roll. I like working dosage calculation problems. But you all let me know what you guys think of dimensional analysis. I'll be doing some more of these. You'll see them coming soon. So, you guys have a great day. I'll see you next time. Bye bye.